And the next one is design for failure. With microservices, there are a lot of processes and a lot of network traffic, which means that a lot can go wrong. A process can crash, the network can go down. When there are a lot of moving parts, the probability that one part will not function properly naturally increases. So how do we deal with that? By writing the code such that it assumes failure can and will happen, and it will handle it gracefully. For example, if the code calls another service, it should assume the service is down, so when an error occurs, it won't throw an unhandled exception, but will try to mitigate it. We will see how in a minute. In addition, extensive logging and monitoring should be in place to catch the errors and raise alerts when they happen. Let's look at a typical microservices system. Here we see 5 services, with the leftmost call the middle one, and the top right calls the bottom right. Now, the code should assume something can go wrong. For example, we might not have a stable network connection between the yellow and the blue services, or even worse, a service might go down. These things might happen. So what should the code do? Basically, 3 things. First, catch the exception. Do not allow unhandled exception to bubble all the way to the client. It will just confuse the user and might even expose sensitive data. Next, it might be a good idea to retrieve the connection. Perhaps it was a little hiccup in the network and everything is now back to normal. It's definitely worth trying. And if nothing else works, log the exception so the developers will be aware of it and analyze it later. By the way, later in this course we will talk about service mesh, which greatly simplifies the way services communicate with each other. So I encourage you to pay close attention when we will talk about it. Another element you should put in place is monitoring. With monitoring, there is another service, usually a third-party product monitoring the services. This product is continuously monitoring the services for problems and is looking at various data about the services. For example, monitoring products usually look at the CPU and RAM of the machines underlying the services and also send is-alive checks to make sure the service is up and running. When the monitor detects a problem, it knows to raise alerts either to dedicated console or to other messaging services such as email or text. Here are some popular monitoring products. I especially like the Azure Monitor and Application Insights. They are dead simple to use and provide great insights. Kubernetes also monitors the service it manages and raises alerts when a problem is detected. We will talk more about Kubernetes in the deployment section of this course. So, what is the motivation behind the design for failure attribute? Well, not surprisingly, the main motivation here is to increase the system's reliability. If the system will be able to handle errors gracefully, it will experience less crashes and will provide better user experience. And that's always a good thing. Great, so that was the design for failure. And now let's move on to the next and last attribute.